Okay, today we're going to talk about a certain type of graph called a graph of direct variation. And this is also sometimes called a proportional relationship. So vocabulary is direct variation, constant of variation, and directly proportional. Now, a proportional relationship is a relationship where the ratio between the input and output remain the same. So 30 miles every 2 hours is a proportional relationship because it would be 30 miles every 2 hours or 60 miles every 4 hours or 120 miles every 8 hours and so on. So the relationship between the ratio of miles per hour remains the same, right? So if it's 30 miles every 2 hours, I could also say it's 15 miles for every 1 hour. Okay, so the unit rate would be 15 miles per hour. Or we write that as 15 miles per hour. Okay, 2 pounds cost $6. So for every $6, this is like a picture of it. There are $6 for every 2 pounds. So 4 pounds would be $12, and 8 pounds would be $18. So every time you add 2 pounds, you also add $6. This is a proportional relationship. Okay. Also, we could go down and say that for every 0 pounds, it's $0. Right? Okay, so if I graph the relationship that we just saw, 2 pounds for every $6, you'll see that you can graph, 2 for 6. So if I graph, so the cost depends on the weight. Okay, so let's say this were I was buying some. The picture looks like maybe you're buying some ice cream. So every 2 pounds costs $6. So 2 pounds of ice cream costs $6. So I would graph the weight on the independent axis or the x-axis, because that's the one thing that cost depends on weight. Right, so the cost is going to be your y, that's the dependent variable, and the weight's going to be your independent variable. So I graph 2, 6. I'd also graph 4, 12, and 6, 18. Okay, and this also implies that there's another point on this line is 1, 3. Let's see, there's 3, this would be 9, right? So the relationship is that the y variable is always 3 times what the x variable is. Okay, this is called an equation that's a direct variation. It's also a proportional relationship. So the relationship between the x and y variables are always the same in this relationship. The y variable is always 3 times what the x variable is. And the slope in this case, y is 3. Remember, this is the equation y is equal to 3x. You can think of this as being 3x plus 0, where 0 is your y-intercept, and that makes sense because the point 0, 0 is on this graph. Or if I let x be 0 in this equation, y would also be 0. So equations of direct variation have these two things that are in common. They go through the origin, and m is called the constant of variation. Okay, so m is if you try to find the ratio of y to x. Okay, if you took this equation right here, y is equal to 3x, and you solved it for the constant, so if you try to get 3 by itself, you could divide each side by x. You'd have y over x is equal to 3. So the ratio of if you look back on all these points here, the ratio of the y coordinate to the x coordinate is always 3. So 9 over 3 is 3, 18 over 6 is 3, 12 over 4 is 3, 2 over 6 is 3. Okay? You can't do 0 over 0 because you wouldn't be able to divide 0 by 0, but every other, 3 over 1 is 3. So every other relationship between x and y, x over y is always 3. So 3 is called the constant of variation. Now let's say that you were driving and you drove 45 miles in 3 hours, or 30 miles, or you drove, in 2 hours it took you to drive 30 miles, in 3 hours you drove 45 miles, and you wonder if this is a proportional relationship. Well, let's see, which depends on which, okay. Let's fill in this sentence. Blank depends on blank. Okay, so the miles depends on the hours. So in that case, the hours goes down here. So hours goes on the x-axis, and miles goes on the y-axis. Okay, so I always put that, I fill in those blanks in the sentence in my head so that I can know which one goes on the x and which one goes on the y. Here it was sort of, it was easier to see because the units on the x and y were already sort of filled out. But if for 3 hours you drive 2 hours and 30 miles, so that would be, it's a little hard to figure out where these lines are right here. So let's just sort of estimate here. 30 looks like about here, and 3 is about right there. Okay, and 4 and 45, so 4 and 45 looks about here. Okay, now that means that in 0, you drive 0 miles in 0 hours, right? So it goes through the origin like that. And if I graph this, this is a proportional relationship because the ratio of y to x, okay, so this was y and this was x, so 30 miles in 2 hours. Does that create a proportion with the other x and y variable that we know? 45 miles in 3 hours. So is this a proportion? So this equation, this equal sign is a question mark. Is it true that 30 over 2 is equal to 45 over 3? And it's true because they all reduce to 15 over 1. So in other words, the y relationship, the relationship between x and y is that the y is always 15 times what the x is. Okay, so 15 is called the constant of variation. So it's a proportional relationship because all of these points on this line create a proportion with each other. The x and y coordinates, the ratio of y over x is always the same. Okay, so there are two things that a line or an equation must have in order to show a proportional relationship. It must be a line, it can't be a curve. Curves are never a proportional relationship. And so you know it's not a curve if the highest power you see on x is 1. So for instance, right here, okay, the highest power you see on x is 1, so this is a line. If it were y is equal to 3x squared, the highest power of x is 2, and that's actually a parabola. That's actually a parabola that looks like that. Okay, and so it must be a linear equation, and it must go through the origin. So in order to go through the origin, that means that the y-intercept is 0. Okay, so the equations are all of the form y is equal to mx plus 0, or, you know, you don't have to write that part, right? So the equations are all of the form y equals mx. Okay, so every proportional relationship looks like this equation because it passes through the origin, and the highest exponent you see on the x is 1. All right, so which graphs show a proportional relationship? So it must be a line. Okay, these are all lines, and it must go through the origin. So this one is not a proportional relationship, this one's not a proportional relationship, and this one are. Okay, so we can actually figure out the equation of these lines. We can figure out the slope of these lines by looking at the rise over the run. So this relationship, we know y is equal to, the slope is 2, so it's y is equal to 2x. And here, the slope is -1 over 1. So -1 divided by 1 is -1. So it's y is equal to -1x, or y is equal to -x. Okay, that's the same as y is equal to -1x. Okay, so if you were to describe a proportional relationship from, like, you should be able to be given a verbal description of something and tell whether or not it's proportional. Okay, remember, proportional is everything in this form. Okay, relationship between the radius of a circle and its diameter. So let's see. The diameter is always 2 times the radius. Okay, so if the diameter is y, that's always equal to 2 times if the radius is x. And it looks like this is in the form. Okay, the highest exponents that we see are 1s, and one variable is always some number times the other variable. Okay, it's like it wouldn't be a proportional relationship if it were diameter is equal to 2 times the radius plus 4, for instance. Okay, but since it's this equation, the answer to this one is yes. Okay, the relationship between the radius of a circle and its area. So area is equal to pi r squared. So this is not a proportional relationship because although pi is a constant, the highest value we see for the exponent is 2. Okay, so that's going to make this equation be, when it's graphed, it's going to look like a curve. It's going to look like some sort of parabola. Okay, so this is the answer to number 2 is no. The height of the water in a glass if the water is empty to begin with, and the glass fills at a rate of 2 inches per second. So if it was empty, and if we go time versus inches, okay, if those are our coordinates, okay, at 0 seconds, there's 0 inches of water, right? And at 1 second, there's 2 inches of water. At 2 seconds, there's 4 inches. So you can see that it starts at the origin, okay, because it didn't have any water. It was empty to begin with. So at time 0, there was no inches in there. And the relationship between your x and y variable is always constant. The y is always 2 times the amount of seconds. So the number of inches in the glass is always twice the amount of seconds that they've been pouring. So the answer to number 3 is yes, it's a proportional relationship. The height of the water in a glass, if the glass starts out with 3 inches of water, then the water fills at 2 inches per second. So if it starts at time 0, then it's 3 inches of water. After 1 second, there's, 5 inches of water. At 2 seconds, there's the initial 3 inches plus 4 more inches, that's 7 inches. Okay, so it almost looks like, if we just do the ratios of x to y, right? So let's see, let me make this a little bit smaller here. Let me just give myself some space here. If you do the ratios of x to y, you'll see that the ratios are not the same. So our initial point was 0, 3. Actually, we can tell it's not a proportional relationship because it doesn't start at the origin. Okay, 0, 3 is not 0, 0. Number 3 started at 0, 0, but number 4 started at 0, 3. So no, right off the bat, number 4 doesn't start at the origin, so it doesn't. It's not a proportional relationship. Furthermore, if you looked at the ratios, so after 1 second we said there were 5 inches. After 2 we said it was 7. Okay, the ratio of y to x in the first coordinate is 5 over 1, that's 5. But in the second coordinate, it's 7 over 2. So that's 3.5. The fact that these ratios did not say the same makes number 4 not be a proportional relationship. So those things are not a proportional relationship. So yes to 1, no to 2, yes to 3, and no to 4. Okay, and that's the end of the lesson for today, which is a quick lesson on proportional relationships. Remember, proportional relationships, when they're graphed, they look like lines going through the origin, and they have to be lines, and they can't be curves. With equations, they look like the equation y equals mx, okay? And furthermore, we know that the relationship to the coordinates y over x remains the same for every point on the line. Those are all characteristics of proportional relationships or direct variation. Those are the two. So direct variation and proportional relationships are the same thing.